Hi everyone. In today's video, I will be going over the first quarter benchmark review study guide. Starting with number 1, -2 times the absolute value of x plus 3 equals 14. So the very first step is to always get the absolute value by itself. That's this piece here. As you can see, it is not by itself. It's got a -2 on the front, so I need to get rid of it. Remember, to get rid of a number in front of an absolute value, it is not add or subtract. A lot of students will do that. You add or subtract, there's a symbol in between the -2 and the absolute value. If there were a plus or a minus here, there is not. In fact, I can barely fit a multiplication sign in there. That means this is multiplication, so I'm going to divide by -2 on both sides. Then we end up with the absolute value of x plus 3 equals 14 divided by -2 is -7. Now the absolute value is by itself and we can continue the problem. But I'm actually going to stop here because we have absolute value equals a negative number. Absolute value can never be equal to a negative number. So this here is no solution. This is why it's important to check your work, because we put this at as the very first question. So a lot of you are probably going to miss it. You'll finish solving the problem. You can get some answers, but if you plug them back in, they won't work. That is why it is important to check your work. All right, number 2. Same idea, absolute value of 4x plus 2 minus 3 equals 7. Absolute value is not isolated here. We have to get rid of this minus 3. Now this minus is between the absolute value and the 3, so this is add or subtract. In this case, we are going to add 3 to both sides. Those cancel. Absolute value of 4x plus 2 equals 10. Now this absolute value is by itself. So the next step is we split. So we write two equations here. We have the positive equation and the negative equation. The positive equation is the exact same as what's above. We just drop the absolute value. The negative equation, the absolute value does not change. Never change anything inside of the absolute value. And then we change the right side to a negative. So this becomes a minus 10. And then we solve both of these equations. 4x plus 2 equals 10. First thing I'll do is subtract the 2 on both sides. It's a plus 2, so I minus 2. 4x equals 8. And then lastly, I divide off the 4 on both sides. X is 2. I'll repeat these same steps over here. Minus 2. For x equals -12. Divide by 4. X equals -3. Lastly, I'm going to check. So when you check both answers and you check it into the equation above the split that still has the absolute value on it. You can also use the original equation if you can't remember, but this is going to be just a tad more work because I had a step I had to do first. So choice is yours. You may not use either of these to check your work because they don't have the absolute value, so of course these answers are going to work. You need to make sure they will still work with the absolute value. So I'm going to check with this equation. Absolute value of 4x plus 2 equals 10. And I'll go in order, so I'm going to check x equals 2 first. So we have absolute value of 4 times 2 plus 2 equals 10. 4 times 2 is 8. Don't drop the absolute value yet. A lot of students like to do it. 8 plus 2 is 10. Still inside the absolute value. You can drop it when you get one number inside and you ask yourself the question, what is the absolute value of this number? Absolute value of 10 is just 10, and 10 does equal 10. So x equals 2 is a solution. We still have to check negative 3. Absolute value of 4 times negative 3 plus 2 equals 10. 4 times negative 3, that's negative 12, still inside the absolute value. Plus 2 equals 10. Negative 12 plus 2 is negative 10. Lastly, the absolute value of negative 10 is positive 10. 10 equals 10, it works. X equals negative 3 is also an answer. So, I'm just going to write this as a comma separated list in the blank. X equals 2, negative 3. It does not matter what order you put these in. Alright, we're done with the equations with the equal sign. Now we're switching to inequalities. And remember, our hint up here tells us how to handle these. And before I get started, I do want to point out, on the benchmark, there is another way to express the AND case. It's written up here in top. This is called a compound inequality. So once we do an AND problem, I'll show you how to write your answer correctly after doing that. So I'm going to put that in parentheses next to it. We have A is less than B and A is greater than negative B. So that's how I taught you guys to write it. But there's another way, and the standard way we like to use in Algebra 2 is actually the compound inequality, but personally I prefer the AND, so that's why I taught it that way. On the benchmark, you will have to know how to write this. It's not a major jump from the two, between the two, so I'll just explain it to you when we get there. Number 3, absolute value of 3x is greater than 21. So first things first, make sure this absolute value is by itself. It already is. So now we use the hint to figure out how to set up our problem from here. This is a greater than symbol. We have the bottom case. So we're going to write our answer like this. So A is just whatever's on the left side and B is whatever on the right side. So we have, and we're going to split it up. Still have the positive and the negative. So the positive is what we write first. 3x is greater than 21 if we follow the hint. Or it's just like a 1 and 2, specifically number 2 above, where it's the same, you just drop the absolute value. Or, you cannot forget that or, it's very important. Again, the left side, don't change a thing about it. 3x is we flip the sign, less than, and we change 21 to a negative. So you flip the inequality and change the sign. This is our setup, now we solve. 3x, so we just got to divide off the 3 on both sides. 3's cancel. X is greater than 7. Or, same thing over here. Divide by 3. X is less than negative 7. And remember, this entire thing is your answer. I have some students who just want to put the inequalities. That's wrong. You have to include that word or. Some students just put the numbers. That's even worse. I'm going to rewrite that exact thing up here. X is greater than 7 or X is less than negative 7. There we go. Number 4. First off, our absolute value is x plus 1 in here. Just identify it. 4 times the absolute value of x plus 1 minus 6 is less than 14. As you can see, this is not isolated, so we have some work to do first. So, some students will divide first. You never divide first. You will divide at the very end. If you divide 6 and 14 by 4, you're going to get decimals. Don't want to do it. First thing you want to do is move the 6 over. This is a minus 6, so I'm going to plus 6. Four times the absolute value of x plus 1 is less than 14 plus 6 is 20. And then the last thing we can do is divide by 4. And now is a good time to divide by 4 because 20 divided by 4 is a nice number. Remember, I know this is division because I can barely fit a multiplication sign in between the two. Nothing else, not a plus or a minus. So no adding or subtracting here. Divide by 4. 4's cancel. We have x plus 1, absolute value, of course, is less than 5. So this is where we're at. Next, we're going to split to the positive and the negative, using our hint to help us set it up. So I taught you the and way, so we're going to use that, and then I'll show you how to write this answer like the compound. So let's back up here a moment. This is the less than symbol here. That's the top line. And again, we're going to use what's in parentheses, and then we'll write our answer as a compound at the end. So A is less than B, so we write it the same way as it already is. We just drop the absolute value. So we have x plus 1 is less than 5. So I didn't change anything, I just dropped the absolute value. And same thing on the left side, don't change anything. X plus 1 is greater than, we make the right side negative, negative 5. And now we solve. Just going to be a very simple one step here. This is x plus 1, so we're going to minus 1 on both sides to get rid of it. X is less than 4. And repeat. Minus 1 on both sides. X is greater than negative 5 minus 1 is negative 6. Now, on the benchmark, your answers are going to look like this. They will not look like the and, so you need to know how to write it like this. So, our answer is x is less than 4 and x is greater than negative 6. So, if we look here at how it's arranged, we're going to set up the two symbols first. So we're going to put an x in the middle. X is the A. And then this is kind of self-explanatory conveniently because we do have a positive and a negative number. So you put the larger number, in this case the positive number, on the right side. So this is a 4. And then you're going to put the smaller number, in this case the negative, on the left side. So now you see we went from the and statement to, this is called the compound inequality, very easily. You put your x in the middle, and then you put your bigger number on the right side and your smaller number on the left side. And this is like saying, just for context, x is between negative 6 and 4. That's how it works. So that's the convenient thing about the compound inequality. It's a very visual thing. So this is the official answer I want you to write. Negative 6 is less than x, less than 4. On the test, your hint is going to look like this. So I don't want you to freak out. You will have this little helpful conversion between the two. But again, the answers will look like this, not like with the and statement, unfortunately. So you do have to know the comparison between the two. All right, next page. Number 5, evaluate the piecewise function. So here we have our piecewise function. F of x equals 3x minus 4 if x is less than or equal to negative 6. F of x equals negative 9x plus 2 if, here's another compound inequality, you can read this as x is between negative 6 and 6. And again, I can write that between, if that helps. Or f of x equals negative 3x plus 4 if x is greater than or equal to 6. So, A, find f of negative 6. Reminder, there's supposed to be an x here. So when you have a number inside, that means it's directly telling you x equals negative 6. So what you do, these are conditions. So that means your x must meet this condition before you can use this equation. So don't plug it in here first and then check it in here. You're going to waste your time. plug it into here first and see which one works. Then you're going to use that equation that goes with it. So we will start with the top and work our way down. So top, our x is negative 6. So negative 6 is less than or equal to negative 6. Ask yourself, is this true or false? Is negative 6 less than or equal to negative 6? It's equal to it, so it works. Since it passed the first test, we're going to use this equation. F of x equals the top equation, because that goes with that inequality, 3x minus 4. And then all you do is you replace, anytime you see an x, I'm going to put parentheses. You replace the x with the number that has been assigned to it. So we're going to replace x with negative 6. Now from here, we don't do anything to the left side, because remember, we're trying to figure out what this is. So this stays as is. The right side, we just need to figure out what number this whole thing is. So 3 times negative 6, order of operations, we need to multiply first. 3 times negative 6 is negative 18. Bring down the minus 4. F of negative 6 equals negative 18 minus 4 is negative 22. So 5a, you can either write the whole expression or you can just write negative 22. Both answers are correct. I'm going to write it in fully though. Let's repeat that for 5b. Find f of 3. Again, this is telling us that x is 3. From here, I'm going to go through and test it till I find the right one. So first, let's try the top one. 3 is less than or equal to negative 6. Ask yourself, is this true or false? Is 3 less than or equal to negative 6? Not at all. It's bigger than negative 6, so it fails. Let's try the second one. Negative 6 is less than, our x value is 3, less than 6. So again, this is asking, is 3 between negative 6 and positive 6? Yes, it is. So it passed. So we're going to use the second equation, because that's what goes with that inequality. F of x equals negative 9x plus 2. Same process. Anytime I see an x, I'm just going to put some parentheses. So negative 9 parentheses plus 2. And then x is going to get replaced with a 3 because x equals 3 here. So then we have f of 3 equals negative 9 times 3 is negative 27 plus 2. Bring that down, plus 2. F of 3 equals negative 27 plus 2 is negative 25. So this is our answer here. So we have f of 3 is equal to negative 25. 6 and 7 both go with this graph right here. We have f of x on the top and g of x on the bottom. Questions 6 and 7 refer to the absolute value graph shown. The graph shows g of x is a translation of f of x equals the absolute value of x. So f of x is just the absolute value of x. This is the parent function, meaning it starts on the origin. There's no changes made to the graph. This is your watered down, simplified, basic graph of an absolute value. Now g has clearly taken f and moved it over here. So you track the change from the origin, so the vertex, down to where it is now placed. You're going to track this change right here. So this is left 3, and then down 5. So those are the changes. So on 6, when it says state the transformations, there's only 2 transformations. Left 3, down 5. What is the equation of g of x? Okay, so we have our f of x equals the absolute value of x right here. And remember, we can write transformations into the equation. So let's talk about how this looks. So left 3, inside of an equation, it's going to go inside of that absolute value of x. Remember, x lies, so you would think we're going to put x minus 3, but we're actually going to put x plus 3. Remember, x's lie to you. So it looks like a right 3. This is actually left 3. Down 5. This one's the easier one. This one's not going to lie to you, so you do write a minus 5, and that's going to go at the end of the equation. So putting it all together, we have f of x, or sorry, g of x. Hang on a second, I'm going to fix that. All right, that looks a lot better. So g of x equals, and then we're just going to put this together, absolute value of x plus 3 minus 5. And that's it. That's our new equation. Number 8. Write an equation that shows the transformation of 4 units up, 9 units to the right, and a reflection of the x-axis of the parent function, f of x equals a times x minus h squared plus k. So all we're going to do is we're just going to go through this piece by piece and figure out what numbers need to go where. So let's start with a. Remember, a has 2 things involved. The reflections, and then the stretch or the compression. It just depends on the problem. So let's look back in the directions. We do have a reflection here. And remember, reflections are negative. So we're going to put a negative there. Now, we weren't given another number, so we can just put a minus, a negative in front of the parenthesis, and we're good to go. If you want to write a negative 1 there instead, you're welcome to do that. Next, we have the x minus h part. That is a left or right transformation. So if we go back through the directions, there's 9 units to the right. So we write this, x, and again, x lies. So you would think plus 9, it's actually going to be minus 9. And then I'll go ahead and put that squared in there. And then lastly, plus k, this is going to be an up or down. In this case, 4 units up. And k doesn't lie to you, it's not with its x. So when it says 4 units up, it's plus 4. And actually, I've practically written the equation, so I'm just going to bring the f of x down. This is our final answer. I will write it again one good time over here, all in the same color, if you can't quite fully see how it should look. So there's the answer written all in ink, but I would take this as well. Just depends on the person. Usually my setup doesn't look this nice, so it worked out for me this time. Okay, number 9. Given the following function, g of x equals 4 times x minus 3 squared plus 1, state the transformation from the parent function, f of x equals x squared. So this is the opposite of what we just did. Instead of giving us the transformations and telling us to make an equation, they give us the equation and ask us what are the transformations. So we're going to take this apart. We're going to start with this number in front, 4. 4, remember, is that a value. And when you have a number bigger than 1, we call this a stretch. So this is a stretch of 4. That's how you say it. If this were between 0 and 1, so usually written as a fraction, we call that a compression. Next, we have x minus 3. So remember, this looks like left 3, but it's a liar. So it's actually right 3. even though it looks like left, it is right. Right 3. Lastly, we have the plus 1 at the end. Remember, K doesn't lie to you, it's going to tell the truth. So if it says plus 1, it is truly up 1. And there you have it. Next page. Questions 10 through 13 refer to the graph of the polynomial function shown. So number 10, we're going to state the domain of the function. I'm going to go through this fully for those of you still struggling with this. So domain, these are your x values, left to right. So we look at the x-axis when we're doing this. So let's find the left side of the graph. The left side of the graph is right here. It's an arrow, and while it is going up and left. So it's making its way this way to negative infinity. We follow the graph, and we just want to see a nice solid line the whole way, which is what we have. And then we stop right here. Again, it's going up, but it is pointed to the right, so it's moving slowly to the right towards positive infinity. So this is a classic case of negative infinity to positive infinity. Number 11, state the range of the function. Range, these are your y values. And we go b to t, bottom to top. Make sure you do this. You're less likely to write your range incorrectly if you go in the right order when you're looking at it. So first we find the bottom of the graph. Ask yourself, how low does it go? The lowest the graph goes is right here at -4. So we're going to start at -4. And it's on solid graph, which remember is like a closed dot. So it gets a bracket, comma. And then we follow this upwards. Again, making sure there's a solid line somewhere the whole way. And both of these arrows end up here, and they're going up. It doesn't matter which one you look at. They're going the same direction. They're going up to positive infinity. And infinities always get a parenthesis. So there's your range. Number 12, state the coordinates of the y-intercept. Remember what the y-intercept is? Where the graph crosses the y-axis. So here's the graph, here's the y-axis. Where do they cross? They cross, it's a little hard to tell, but right here, that's where it crosses. If you look closely enough, you can definitely see it starts not creating a little bit of a gap, a space here after the 5. So it's definitely not at 6. It's at 5. So make sure you write this point in the right order. The x value is 0, the y value is 5. So 0, 5. Lastly, write the equation of the graph. So first off, you need to know what this is. This is a quadratic. So this is, and you can write f of x or you can write y. It depends on the person. I'm going to do f of x because that's what we've been doing on the whole study guide. So I'm kind of in that habit. But if you write y equals, that's fine. F of x equals x squared. And then also we need to take into account that this is not on the origin. So this is not our equation. We have transformations. So again, you track what changed from the origin. So this is right 3 down 4. That is how the graph has changed. So right 3 means in our equation we're going to have x, again, right 3 is not plus 3, it's actually minus 3. X lies to you, squared. And down 4, at the end of the equation, you're just going to write minus 4. Because this tells the truth. All right, let's put that together. F of x equals x minus 3 squared minus 4. And that's it. I am going to stop the video here because I am running out of time, and I will finish 14, 15, and the last page in a separate video. So go check that out when you're ready. I hope you guys have enjoyed this video so far. I hope it's been helpful, and I will see you in the next one. Bye!